Hey, I was doing super fun stuff yesterday. I got a bunch of cups laying around in the classroom. I started stacking them up. They're just laying all over the place. So I started picking them up, and I was going to put them away. And I got to myself thinking, like, I wonder how many cups it would take to be as tall as me. Um, so go ahead and make a guess. Hit pause. I'll wait till you get your guess written down. You've never seen me, maybe. I'm pretty tall. I'm like this tall, like six one and 3/8. Yeah, okay. You probably need to know that. Okay, so we're going to use that guess to kind of point us off in this direction. So we're going to learn about function notation today. Two parts of the learning target. You'll be able to put a number in for x using function notation. You'll be able to solve to find x using function notation. We don't even know what function notation is yet, but anyway, that's where we're going. So we're going to we're going to use these cups to get there. So I took some measurements because you guys don't have access to the cups. I measured one cup, 9 centimeters tall, and then I measured 11 cups stacked together, and the total stack of 11 cups was 17 centimeters. Okay, so we need to find out a couple of questions. First, what's the difference in height between the 9 centimeters? One cup is 9 centimeters, 11 cups is 17. So we subtract 17 minus 9. It would probably help if I had a pen selected. 8 centimeters. Difference in the number of cups, well, this is 11, that's 1, so 11 minus 1, that's a difference of 10 cups. And then we can use those two pieces of information to find out what's the added height per cup. This is, so we're going to go per cup, 8 centimeters, split up into 10 parts for those 10 cups. And mental math, 0.8 centimeters per cup. Okay, so I mean, you guys know what styrofoam cups look like. When you start stacking styrofoam cups, you don't add 9 centimeters every time you add a cup because they nest inside one another. So even though one cup is 9 centimeters tall, you don't add another 9 centimeters every time you add a cup to the stack. It's just this little bit of the rim right there. That's the only thing that's adding height to the stack because all the rest of this disappears inside the previous cup. Well, it doesn't disappear, but goes inside the previous cup and doesn't add any height. Okay, so the first cup was 9 centimeters, and each cup after that, 0.8 centimeters per cup. Um, Under different circumstances, I might try to ask you to try to put together some sort of formula you could use. You could try this anyway. What formula do you think you could come up with that we could use to calculate the height of a stack of any number of cups? If we just said, hey, what about 20 cups? What about 100 cups? We could calculate the height of that just based on these two pieces of information. It'd be a totally worthwhile thing to do, and I probably actually do that in a couple of days. So you can remember this. We'll come back. But here's what I did. I had a lot of time on my hands, and so I measured the heights of how high the stack was for like different numbers of cups. And so I put it into a data table, which you can see here. The number of cups, that's going to be like the X number that we're going to use for the input. And I recorded those 1 cup, 2 cup, 3 cups. I kept going because I had lots of time. So anyway, the blue column, that's the height of the stack, the total height from ground to top of the top cup. Measured in centimeters. So that is, I'm going to abbreviate that with the H for height. Okay, so I'm going to see if we can get both of these to show up at the same time. I want to put these questions on one side, one side of the screen. Blam, blam, there we are. All right, so then we can use the data table to find the height. Well, I think we can look at all of them at the same time. Let's just go in order though. The height is 17 cups. Okay, so I have to let's scroll down here until I found 17 cups. There it is. 17 cups is going to have a height of 21.8 centimeters. Height for 52. All right, let's go to 52. Here it is. 52 cups, 49.8 meters. And keep abbreviating. That's so long to write height of 17 cups. So I put the 17 cups in parentheses, by the way, because that's a group. And we learned about groups the other day. So parentheses are a way to group numbers together. So the 17 cups go together and make a group, right? That's what a stack is. It's a group of cups. So then the height of 52 is now we got h of 93. So let's go to, whoops, that's too far, to 93. So that'd have a height 82.6. 82.6 centimeters. Okay, and I got a second set of questions. We use the data table for these also. So let's see how many cups it would take. I was just curious, I mean, if we took the number of cups a second ago and found out how high it would be. What if we wanted to know how many cups would it take to get this high? What if I needed a stack that was 50, or wanted a stack of cups that was 57 centimeters tall? I mean, who doesn't want a stack of cups that's 57 centimeters tall, right? That's pretty common for people to want. Okay, so I'm going to go in my data table. I'm looking for the height this time. So in the blue column, I need to find a height of 57. There it is. It would take 61. 61 cups. So that would be like the x I put over here, the height of some unknown number of cups. The height of x cups was 57. Well, this 61, that is the number of cups. That's my unknown. Next question. What about the height of an unknown number of cups, x, which would be 98.6 centimeters? All these temperature checks for COVID got me thinking 98.6. So let's go to the height of 98.6. Does that show up? Scrolling. There it is, 98.6. That's 113. Unknown number of cups, x is 113 cups. Okay, last question. What if I wanted to get a stack of cups that's as tall as me? This is what you guys guessed, even though you've not actually seen me. That's okay. So 6'1" and 3/8, something like that, converted to centimeters is 186.6 centimeters. So let's find the height over here. I got to scroll. 186.6 centimeters. So I'll keep going. There it is. 223. 223 cups. Oops. All right. Well, hey, I wonder what your guess was like, if you were pretty close or not. So here is the takeaway for us. We're trying to learn about function notation, and I've done some abbreviating here. So this is on purpose. It's intentional. This is in order for us to actually get to our learning target. It's not just a, hey, let's do a fun thing with cups that has nothing to do with anything. So I started off with something that was kind of like a sentence, sort of, but mathy in a way, right? So the height of 17 cups. And I put parentheses around the 17 cups because they're grouped together. Okay. I mean, we wouldn't normally do that, but it makes sense. And so then I didn't want to write as many words. So I said, hey, height, and then, so we know we're talking about, and I put 52 cups inside the parentheses. It's still a group of 52. And then I wanted to abbreviate even more. And so instead of that whole word height to label what we're doing, I just used the H, because I think we all know that the H means height. And inside the parentheses, I put 93 because that's the number of cups. That's what I'm trying to input, this many cups to the stack, and then try to get what is the height. Okay, that's function notation. When we have some sort of data or a graph or an equation, we can give it a label so that we know what we're talking about. In this case, we're talking about height. In a different case, maybe we're talking about how much money somebody earns by working, this number of hours. There's lots of different things that we could do. And so function notation, one of the things it does is it gives us a way to label. And it labels not just the name of what we're talking about. Whoops, that's not what I wanted to change. Okay, the H telling us what it is we're talking about. We're talking about height, but it also tells us that we're inputting whatever number is inside this set of parentheses. That is the input. And most of the time we can change our variables, but most of the time that's going to be x or whatever we've changed the x to. If we're using different letters, we don't always use x and y. Like I didn't have a y, I've got an h. So, but the input or the x coordinate on a graph, we have an x-axis. Okay, so the number inside the parentheses will always be the input. And then over here, I also used function notation. So I'm still talking about h is the height, and inside the parentheses, that is my input or the x number. But for this series of questions, I did not give you a number of cups. We had to find out. It was a mystery number of cups. What I told you was the output. We're looking for a height of cups that was 186.6 centimeters, and we had to work backwards, well, in the other direction on our table, to find out the number of cups that it would take. Okay, so just as a check-in, here's two questions. Explain what these questions are asking, I mean, one at a time, so we'll call it question one and question two. Explain what this question is asking. If I said h parentheses 25 equals, not the answer, I don't know what the answer, just what does that mean? And secondly, explain what this other question is asking, the h and then parentheses x equals 29. And again, I'm not looking for the number answer, whatever that would be. I just want to know, what does this mean? So I'll hit pause and I'll let you answer. Okay, I got my answers. You got your answers. So hopefully we came up with the same thing. This one is asking us to find the height of a stack 25 cups. This one is asking us how many cups it would take to get a stack that is 29 centimeters. Needed for a stack 29 centimeters. Okay, so we can keep track of the units. Inside the parentheses, this was number of cups, and the number after the equal sign, that's centimeters. And in our data table, I had them labeled that way also. The X, the green column has a labeled with X, and that is a number of cups. And the blue column, the height, I labeled that as is measured in centimeters, and I labeled it with H of X. So there is our function notation, right? So just to summarize, that's not actually what's due today. Um, function notations. Function notation, the H in this case is the label, and it means height. The number inside the parentheses means the input, it's the number of cups, and after the equal sign, that means the height. Okay. Um, when we see function notation, a lot of times it's going to take the place of the y in an equation. We don't always have it attached to an equation. Like today, we're going to be working with tables and graphs and stuff. But when we do see it with an equation, or even without an equation, it often takes the place of y. So instead of like an x and a y, we're going to have an x and an f of x, the f standing for function notation, or it could be h of x if we're talking about the height of a stack of cups. So it could be whatever label makes sense based on the problem we're doing. And so this is like one of the only places where we get to break a rule. So we know if you write two quantities right next to each other, like a letter and another letter, or a letter and a set of parentheses, that means multiplication, right? And this is a chance for us to break that rule. With the f, with the parentheses and the x, is not multiplication. It's not multiplication. It's an abbreviation. It stands for function, and the number, the x, whatever or number that is inside the parentheses represents the input. And so I know that's weird. Like, why do we have a rule that this means multiplication, except it doesn't? I can't answer that. I don't know. But this is the only time where you write two letters next to one another, and it does not mean multiplication. Okay, so one of the things, kind of a little bit less important, but one of the things which, I mean, kind of less important for what we're going to apply it for today, is that if you see an equation or a graph or a table that's labeled with function notation, like f of x or h of x, this is pronounced f of x, even though there's not the word of there. That means someone else has already done the work of deciding this is a function, like we were doing yesterday. And so that is something that's being communicated here and is important for us to keep in mind.